So welcome and thank you for watching this introduction to our STEM challenge. We're really excited for you to take part in this and learn about how evidence can be used to inform policy. Today we'll have 5 presenters spread across government. So we'll start with the introduction from myself, Stephen. I work in the Defence Science and Technology Laboratory. Then Ben in the Department for Health and Social Care. We'll look at the challenge we're setting. Rob in Department for Environment, Food and Rural Affairs. We'll link this in with jobs people do already in the civil service. Kunan in the Ministry of Defence will give practical details on the project, and then Maria in the Department for Environment, Food and Rural Affairs will take you through how the results will be judged, and then we'll enter in some questions. Sorry if we use any acronyms or jargon during this. The civil service loves an acronym, so please do contact us afterwards at GSE at go-science.gov.uk. If you need or want any more information, we'll do our best to answer any questions. So on the next slide, it asks, who are we? And we're civil servants, and the civil service is there to help the government of the day develop and implement its policies. At the heart of this are 4 standards: integrity, honesty, objectivity, and impartiality. And this guides all of our actions. And within the civil service is the government science and engineering profession. This is led by Sir Patrick Vallance, who you might have seen at the press conferences over the last year. There are over 10,000 civil servants with STEM backgrounds in specialist roles where they do research, policy, analytical, operational roles, all making sure that the best evidence is there and advice is there for decision making. And we're on the Science and Engineering Fast Stream, which is a graduate scheme for people entering into the civil service with scientific backgrounds. We have all sorts of backgrounds, from biologists and chemical engineers to economists, civil engineers, anything you can think of. And then we have all sorts of roles that we go into, working from DEFRA in natural capital to Department for Transport with low emission planes, and then into the military and looking at how we can defend the country. So we thought it would be really good to hear the stories and insights from a few of the people on the fast stream. We've got a few recorded clips, starting with Kunan.
Hi everyone, my name is Kanan and I currently work for the Army as a scientific communications officer, and as with many of my colleagues that will be speaking with you today, I'm also on the Civil Service Fast Stream, which is a leadership development programme for aspiring civil servants. So I think the main thing I'd like to say really when it comes to science, and whether it's working in the civil service or working elsewhere, I think one of the great things about having a career in science is the fact that you can apply it to almost anything, and depending on what you're passionate about, what you want to work in, or what you want to base your career around, there's always a place for science in that. So for example, if you're passionate about sport, then absolutely 100% there's a place for science in that. Or if you're passionate about climate change, then again, science plays a massive part in how we understand and tackle the current climate crisis. So whether it's that or anything really, it could be anything to do with digital work, or it could be anything to do with housing, transport, or in my case, defence. There's always a place for science to sort of coexist in those career areas and make a massive contribution as well. I think nothing more prescient than COVID at the moment, and of course if it wasn't for scientific minds, people like Chris Whitty or Patrick Vallance doing the work that they do, then we wouldn't be able to mount the COVID response that we've been able to mount really, and so science has played a massive part in that as well. So yeah, I think just basically if you're passionate, whatever you're passionate about, there's always a way to sort of fit science in and be able to make a great contribution, whatever your passion might be. So I think that's probably why I would recommend a career in science, and hopefully this challenge will give you a little bit of a taste of what that could be like. So I hope you enjoy the challenge, and have fun with it.
Hi everyone, I'm Robert and I'm a first year fast streamer on the Science and Engineering Fast Stream in the Civil Service. And I am going to briefly outline a bit about my background, what led me to this point, why science is important for policy, and what job I'm currently doing. So my background is in earth sciences. I did an undergraduate master's degree in that, which essentially meant I looked at rocks for quite a lot of the time. I looked at the ocean, I looked at climate, and I looked at sort of the interlinkages between these and a whole host of different things. And I really enjoyed university and learned a lot, and I was very interested in putting this background to a very practical use. And I thought that the civil service could be a really great place to do this, a really great place to help influence decision making and policy making. And I think science is really important for decision making and policy making a lot of the time, and it can provide the evidence or one suite of the evidence, and it can also help sort of actually deliver on the policy, deliver on the decisions that are made. Noting that decision makers also take into account other things as well as science, but it can be a really key part. And I think there are lots of things going on across government that are really using science at the moment, which is really exciting. But in terms of what job I'm currently doing, I work in the Ocean Climate team in the Department for the Environment, Food and Rural Affairs, or DEFRA. I look at ocean and climate and everything to do with that. I look at coastal ecosystems, ocean acidification, research and development projects, international engagement, and a wide variety of different things. And I've really enjoyed being able to put my degree to use, but also being able to meet some really talented, some really enthusiastic people across government and externally, and just learn so much about the topic, but also sort of how to operate in a government environment as well, and with decision makers, and that's been really interesting. So that's it from me. Thank you.
Hi everyone, I'm Amber and I'm on the Science and Engineering fast stream, currently placed within the Home Office. So my background, I did biomedical science at university, which is essentially human biology. So anything from the individual cells right up until anatomy, so general how the organs are and how your bones all fit together. So it was a very interesting degree, but I quickly learned that working in a lab was not really what I wanted to do. I prefer interacting with people and prefer more the translation of science into policy and into the world, really. So I then studied public health, which is more of the interaction between health and the environment. So say populations and how they interact and how different viruses spread amongst populations, and how what you eat and how much you exercise impacts your health. So this was a very interesting degree to be studying while we had a real life case study going on, the coronavirus pandemic. That was very interesting, and that was actually what then led me to apply for the fast stream, because I knew that I didn't want to do the research. So you can be on the research side right at the beginning, where you can either work in a lab at university or out in industry, so in like pharmaceutical companies, maybe developing a vaccine, for example, or you could be in the communication bit in the middle, which is how to communicate the science. So you could work for like a journal or social media or a newspaper, or you can be at the other end where you're looking at all of this research and all of the publications and translating that into policy or into a product, for example. So for example, in my job in the Home Office, part of that may be looking at the recent publications of SAGE. So different scientists will write papers on their recommendations, and we will look at these, summarise these into a briefing, which then will go to a minister or the Home Secretary or the Chief Scientific Advisor, and they will then feed this into the policy making. So it's a really, really interesting field to be in, and I would highly recommend studying science.
There we go. I hope we've demonstrated that science doesn't just lead to a career in the lab. There's a great need for people who can understand how to interpret evidence and present that in an effective way. And a great number of careers are desperate for individuals who have those skills. And I hope we've demonstrated that to you today. And hopefully you've learned a little bit about how science feeds into policy through those previous videos. So what we're doing today is presenting you our challenge that we've designed to simulate to a degree what some of the work can look like when using science within government. So using evidence-based decision making. So our challenge to you is to come up with a vision of a carbon neutral day in 2050. Climate change is presenting an ever-looming threat, and sustainability is therefore becoming an increasingly important priority in government. So we want you to envisage how science might play a role in making the UK a more sustainable place in 2050. So we want you to get into teams of 3 to 5 students, work together, use teamwork, creativity, but most importantly, evidence and scientific thinking to provide your vision for 2050. And we've got 3 potential problems for you to tackle, and we want you to choose one of these ideas and present to us a poster and an accompanying report presenting your ideas on how to tackle this problem. So the first problem statement that you might want to choose is sustainable food production. So it's becoming increasingly evident that we need more efficient ways to produce enough food to feed the ever-growing population. And we don't just need quantity of food, we need quality. We need it to be nutritious, and we need it to be produced in a sustainable manner. So we want to pose the question to you of how you might achieve this. You'll need to apply systems thinking here. You'll need to understand the food production pathway and all the various elements that feed into it. There's a lot that goes on here. And don't forget to apply your science and engineering skills throughout. And remember that everything has a knock-on effect. So you want to get your farmer's caps on for this one. So yeah, some ideas to consider for making food production more sustainable. You can see them on the slide here, but you might want to consider something such as how you will utilise the limited land available in the UK, and how food production impacts wider ranging areas of sustainability, such as water resource usage. So have a look at those ideas to consider when you're thinking of addressing this problem. And you don't just have to stick to these, you can think of your own ideas as well, but these are just some prompts that might help you along your way. The second potential statement that you could work on is humans in space. So this one is slightly more science fiction, but we don't want the fiction part, we want it to be scientific. So time to look for the stars here and really get imaginative. In 2050, space travel could well become a more common occurrence, with off-world exploring no longer being constrained to the bounds of sci-fi. But how can we do this in a sustainable way to avoid the currently big environmental impact of space travel? So for this one, you really want to think outside the box and get creative, but remember to stick to the science and don't start inventing technologies from nowhere. So some ideas to consider for sustainability within space travel. We've got some on the slide again, but you might want to think about how we can offset the negative impact of space travel, as it's not particularly environmentally friendly as it stands. So, for example, CO2 emissions are rather high. You might want to look at how you can address that problem, and what potential alternative energy sources we might use for space travel in the future. So remember, this one does require a bit of imagination, but there's some interesting science you could incorporate into your answers here. And again, these are just prompts that can help you in answering the problem statement. The final potential problem statement is sustainable housing. So this time we want you to think about the housing sector and how you might modernize that to create an innovative, sustainable housing community in the future. Now, again, here you'll have to think about wide-ranging impacts and all the factors that feed into developing housing. There's various aspects of the production chain that you'll need to consider. Again, some ideas to consider listed on the slide here. So look through those. They might be able to help you in answering this problem, but you don't have to stick to these. But we've got considerations around what materials the houses will be made from and how you'll sustainably source these. How you cope with land pressures, and how you might ensure that the houses are affordable, as that's a very important area to consider with the ever-growing housing market and increasing population of the UK. So again, just consider that you might want to consider these when answering this problem. but be creative and, importantly, use that scientific knowledge along the way. And evidence is important. So now you've seen the problem statements that we're presenting to you, and remember to pick one of these for the challenge. Now we're going to look at how those might feed into a job role in the civil service.
Thanks, Ben. Hi, everyone. I hope you've enjoyed the presentation and the videos so far. And as Ben said, I'm going to briefly outline how some of the problem statements might actually translate into a real world setting with jobs here that are based on example offerings from the civil service across the departments. So on sustainable food production, I think a really interesting role in this is around analysis, and jobs include collecting, processing, analysing and interpreting data surrounding farming and food, producing publications from this data and passing the results on to other organisations, and then effectively using data systems and developing new ones, all with everything in mind and trying to sort of create data that can then be used in policy development and in decision making across government. I think a really key skill here is obviously strong numeracy and coding skills, but good communication skills and having that ability to really collect the data, but then know how to deliver that to a wide audience. I think that's really important. And I think that's something that is important across all the roles here. On sustainable homes, I think there's a lot going on this at the moment, and one example is work on developing policy proposals with other colleagues on sustainable homes and really getting to know who are the different individuals involved in this, who are the planning officials, who are the wider heat and net zero community, who are the business people, who are the industry experts, working with them to get the evidence that is needed to make the decisions on sustainable homes. As you might expect, a really key skill here is the ability to work in a team. So really knowing who the key individuals to go to are, how best to interact with people, and how best to sort of use them to get the best information that can then be used in decision making. And I think that's a critical skill here. And then lastly, on humans in space, a really interesting one, and I think complex but fascinating. And roles here include the development and implementation of low carbon fuels and policies around that, securing input from a wide variety of different players, noting that this is quite complex, so there are a lot of different experts in different places, and then producing evidence for senior government officials, for ministers and for others across the government space. Obviously, a key thing here is to really have that relevant experience and knowledge. But again, strong verbal and written communication skills are really key, especially because this is so complex that you need that ability to actually take that knowledge and take that information and then make it something that we can all understand and all can use. So I hope you've enjoyed this brief run through of the different roles that might be in some example departments: Department for Environment, Food and Rural Affairs, Department of Business, Energy and Industrial Strategy, Department for Transport, Ministry of Defence, and a lot of other departments as well. But these are just a snapshot of some of the roles. I'm now going to pass on to Kinan to discuss a few more things. Thank you.
Thank you, Rob. So for the next few minutes, I'm just going to be talking to you a little bit more about the challenge itself, some of the logistics, and a little bit of guidance as well in terms of how this challenge is going to run. So firstly, if you are one of the lucky schools who are participating in this challenge and you are watching this video, then we're pleased to say that the challenge is now currently live. So you don't have to wait for a certain date to get started. You can get started straight away, start assembling your teams of students and get cracking with it, really. And the challenge is going to be running until the 11th of June, in which we will be expecting to have the submissions in by 6 p.m. on the 11th of June. In between now and the 11th of June, we're also going to have a couple of additional question and answer sessions, the dates of those which should be in your student and teacher packs. And what those sessions will offer you is just an opportunity for you to come to us in a live setting with any questions that you might have around any of your challenge entries, any problems that you might be having, or if you just want to tell us how you're finding it so far. They're not compulsory sessions to attend, but we do recommend that you come to them, even if you haven't got any questions to ask in the first instance, just because you might hear from other schools about some of the questions that they might have, and that might fill you in on a bit of information that you might otherwise miss out on. So we would recommend that you come to those. After the challenge has closed, in July, we're going to be announcing the winners of the challenge. And later on then in July, we will then be distributing the prizes, which I will tell you in a little bit. Next slide, please. So just to give you a little bit of guidance in terms of what we're expecting when it comes to your challenge entries. So as Ben was telling you earlier, you'll be required to submit not only a poster around one of the three areas, but also a report that goes alongside it. So starting with the poster, so we want it to be an A3 sized poster. It can be landscape or portrait. And keep the minimum font size to about 12, so nothing that's too small to read, but at the same time don't go like size 24 or 30 where you can barely get anything on the page, so minimum around 12. For the poster itself, it should have a balance between some text, potentially some graphs and tables and some images, but at least one graph or table as part of that poster. So we don't want like a big wall of text, but at the same time, we don't just want, pictures, basically. We want to have like a nice balance where you can have a particular graph to show off maybe some data that you found, but a little text to go alongside it, perhaps to explain what the data is about. And the images that you choose as well should be relevant to the particular topic that you've chosen, and hopefully should all come together harmoniously as one really good knockout poster. If you're thinking about what kinds of digital tools might be best for putting a poster like this together, some recommendations that we have include PowerPoint, Prezi, InDesign, and MS Publisher. Ultimately, when it comes to the poster, we would like this to be submitted as a PDF. So if you're not sure how to do that, ask your teacher or just look it up on Google. It's fairly simple to sort of save those posters as PDFs, but that is how we would like the entry for the poster to be submitted. So that's the poster, but for the report, and I know that some of you might be looking at this and thinking, oh gosh, a report, that sounds very serious. Don't worry. So this is just something that needs to accompany the poster and just gives a bit more detail into the scientific background and some of the information and sources that you've picked that has helped to inform the poster. So it gives you that opportunity to tell us a little bit more about the data and the information that you've been referring to, and just to give us a little bit more detail. Don't worry about thinking that it's going to be too long. We're only asking for no longer than 5 pages of A4. So we're not asking for a big 100-page report with lots and lots of detail. 5 pages A4 maximum, with a font size no smaller than 10. And one big piece of advice that I give right now is that quality over quantity when it comes to this report. So we would much rather see a report that was 3 or 4 pages, but every page had some valuable information and was really good to read, as opposed to filling out the word count, but having sort of filler or waffle in there that doesn't really contribute to anything really. So quality over quantity is my advice to you. So that's some of the guidance. And if we just go to the next slides, please. So you're probably wondering at this point, well, what's in it for me? Why do I want to do this? What am I going to get out of it? So there are a lot of benefits into participating into something like this. One of the key benefits is that it's going to give you a really good opportunity to build some skills and experience, especially around that in the scientific discipline. So you may not have heard of things like the Gatsby Good Career Benchmarks or the Skill Building Partnership Framework, but essentially what this challenge is going to give you is experience in problem solving. One thing we as scientists always come across are problems, and we have to use our sort of sets of scientific skills to be able to find answers to those problems. So this challenge gives you a fun opportunity to have a go at trying to solve a particular problem, whether it's sustainable food production, going to space, or sustainable homes as well. It also gives you an opportunity to develop some team working skills, as you will be working in teams of 3 to 5. So this is something, regardless of where you work, even in non-scientific disciplines, teamwork is such a valuable skill that every employer is looking for. So this challenge is going to give you an opportunity to really start to develop those really crucial teamwork skills. And we're also encouraging you, as Ben said earlier, to be creative with it. So we're not asking for magic powered rockets or broccoli that's 20 foot high and can feed an entire village. Nothing unrealistic, but still be creative with it. It's got to be sort of somewhat grounded in scientific reality, but that doesn't mean it has to be sort of boring. So if you've got any really good ideas, then be bold with it, put it down, see if you can get something to work. And in terms of the career benchmarks, this challenge will help to link in terms of building those core, building that core experience and building those skills. That's going to become valuable to you when you do eventually enter the world of work, and if you want to pursue a career in science. And ultimately, it does also give you the opportunity to interact with some science and policy professionals in the civil service, such as us. So that's always a bonus. But even then, after all that, you're still thinking, well, there's got to be something a little bit more than that, isn't there? Well, luckily, for the winners of this challenge, you will receive a prize. And that prize, as you've probably already seen from the slide, will be an achievement certificate from Sir Patrick Vallance, who's the head of government science and engineering. His picture's down there on the bottom. I'm sure you've seen him on many a BBC programme giving COVID briefings. So you'll get an achievement certificate personally signed by him. And if that's not enough, the participants from the winning group are also going to get Amazon vouchers worth £25 each. So it's just something a little extra there. You can buy yourself a little sort of scientific test kit if you want to, but depending on what you want really. But the winners are also going to receive that prize as well. So I think that's it from me. I think now we move on to the frequently asked questions.
So the next question is, what are the judging criteria? And I think I'll pass over to Maria for this.
Yeah, absolutely. So entries will be marked against 5 criteria. These are problem solving, evaluation, scientific evidence, presentation and communication, and creativity. So I will discuss these in a little bit more detail so you know what a good group entry will look like. So under problem solving, we'd like you to introduce the chosen problem and provide context and background information to the problem. We'd also like you to present 3 solutions and explain how each of these will help to solve the chosen problem. In evaluation, we'd like you to evaluate the proposed solutions, suggesting why they would be the most effective ways to tackle the problem and identify any potential drawbacks of the solutions. It'd be great also if you can show consideration for the cost and practicality of implementing the proposed solutions, and we would also like to see consideration of what evidence is missing and where the knowledge gaps remain. Within the scientific evidence criteria, we will judge your ability to selectively use relevant and the most up-to-date information available on your chosen problem and include a range of evidence. So that could be facts, conclusions, opinions, and ensure that these are all clearly referenced from all sources of evidence. Within presentation and communication, we would like your poster to be visually engaging with a logical layout and design, and the report must be well structured, clearly written, concisely and persuasively written also. For the final criteria, creativity, we would like your own ideas to be presented with evidence and ensure that your own interpretations are used of existing material. This also includes producing original graphs, charts, or other visual aids to display this information. Good group entries will include a reflection log, so reflect on the communication and collaboration that you've had during this project with other team members, as well as the skills you feel you've developed during the project. Yeah, I'll pass over to the next slide for the next frequently asked question.
I think I'll briefly outline some answers to some of these, and then I'll pass on to some other members of the team who will give a different perspective on some of these. So the first question is, what are STEM careers? And I know STEM's often, I often don't know what it means, and I think it's a word that's often used in many different contexts, but it means science, technology, engineering, and maths. And I think STEM careers can cover both a wide variety of different topics and a wide variety of different environments, from environmental work to health work to games development to a wide variety of other topics. And that can involve working in a laboratory to working on a computer to working in an office to working with policy colleagues like us. And so it can really encompass sort of a really broad range of different careers, a broad range of different topics, and is, well, I think, and I might be biased, but is very interesting. So I'm going to pass over to the rest of the team and see if there's anyone else who has anything else to say from their perspective.
So I spent 5 years working in a lab during my PhD and masters, and afterwards I decided that the lab wasn't the right place for me, but I wanted to apply my scientific thinking elsewhere. And it surprised me just how many career options there were outside of the lab. So I looked at jobs in technical consultancy, science communication. So that could be working in a scientific journal or even working as a journalist, a scientific journalist. And ended up joining the civil service just because of the wide variety of possible roles within the civil service that involve science. So I really want to kind of emphasize that it doesn't just rely on lab work being a STEM, having a STEM career. It can involve a wide range of things.
Yeah, I would just echo that sentiment that a STEM background opens up so many doors and opportunities to you to work in a huge variety of different areas that may or may not use directly science, but use those skills day in, day out. For me, similarly to Ben, I was lucky enough to kind of work in a lab, and the opportunity to discover new things and be the first person to do experiments and to see certain things happen is so exciting. And then to move into more of a policy setting where it's about using science and evidence in decision making is a completely different view on it, and exciting again to be able to make a difference and to be constantly challenged and to have to analyze and go into detail and be innovative. So it's hard to define a STEM career, but from my experience, they all seem really exciting and varied.
I would agree with what everyone said as well. I think that I found during studying my masters, I found that there was absolutely loads of primary research that was already out there, so much of it, but I didn't feel it was actually getting used. I felt there was so much research that wasn't being implemented or being used to create or inform anything. So my kind of drive towards my current career and in STEM is actually using and synthesizing all that fantastic research that is out there and getting it to the forefront of policy and bringing it to the attention of ministers so that change can actually be made from this research. But yeah, that's kind of that's a big proportion of the work that I do as an evidence manager.
Thanks, everyone. I think we'll move on to the next question. That's okay. Thank you. So the next question is, what does a day in the life of a government scientist look like? And I think this is, as mentioned before, extremely varied. So I'll be pretty brief here, and then I'll pass over to Kinan and then maybe some of the others as well to outline a bit about their work. But I think a general day involves a mix of different things, from looking at emails and responding to requests for scientific information or advice, to being in meetings where you can really promote science to those who are making the decisions, where you can really sort of influence those policymakers and decision makers, to reading a wide variety of different texts to get background information that you can then use in meetings and on emails. And also, I guess, more interesting and fun things such as getting involved with these sorts of activities, or having the opportunity to sort of get involved across the departments on different sort of non-work activities, which is always very enjoyable as well. So I'll pass over to Kinan and then maybe some of the others as well, just to outline a bit about their day in the life.
Thanks, Rob. It's quite a tough question, actually. I think to sort of preface it, agreeing with what everybody was saying before, is that a government scientist isn't just like somebody in a lab coat. They can do so many different things, working across a variety of different sectors and in different areas of research as well. So for myself, working in the Army as a communications officer, I'm working currently a lot more on the tail end of the sort of research journey. So a lot of what my role involves on a day-to-day basis is going working closely with a research team that do a number of research projects on injury prevention and optimizing physical strength for service women in particular in the Army, and really getting to understand what their research is trying to achieve, what their findings are, and for me, most importantly, how they want to communicate it. And then as I'm doing that, I also work with a number of Army communications stakeholders to best understand how to translate what is a really complex set of data to a modern audience, essentially. So whether that's translating it into simple to understand infographics, newspaper or magazine articles, particular blogs, or using internal and external sort of social media pages, translating the information that comes out of the research team and sending that to a desired audience in a way that they can understand it. But as the others can attest, there's different stages of a sort of the life cycle of a research project, and there's different ways to be involved in all of them. But for me personally, being at the end of it and doing that last step, turning research into well understood communications, pretty much forms what I currently do as a day-to-day as a government scientist.
Yeah, so I'm in the Department of Health and Social Care, and my day-to-day, as everyone has said, is incredibly varied too. I work on rare disease policy myself, so that involves a lot of stakeholder engagement. The rare diseases community are a very large community, with rare diseases affecting over 1 in 13 people in the UK. And there's over 7,000 of them. So you can imagine there's a lot of different people who want different things for rare diseases, want their own treatment to be made available. So that involves a lot of engagement with the community. It involves engagement with various arm's length bodies, such as the NHS England, for example. And it involves engaging with ministers as well. And no day's the same. That's what I'd like to emphasize. No day's the same. And there's always something interesting that crops up to get involved in.
Great, thanks everyone. If there's no more points for anyone, I think we'll move on to the next question, please, Ben. Thank you. So a question here about the different topics, and can we go beyond the topics that are provided?
Yeah, I can add, as a member of the judging team, we would like you to stay within the scope of the topics that have been provided, and that is what you'll be marked on. However, as we've already heard from Robert, you can find really innovative and exciting things within those topics, and we want you to think outside of the box but still stay within those topics for the best marks.
Thanks, Maria. So I think this is the last frequently asked question, which is, who do we contact if we have questions outside of the Q&A sessions that Kinan was discussing earlier? And I'll pass over to Stephen for the answer to this one.
Yep, so if you have any questions, please do get in contact with us. We'd love to hear from you and love to be of help in any way we can. So send us any questions to the email address gsc@go-science.gov.uk and put STEM challenge in the subject. Other than that, that email address will be available in the packs that have been distributed, and we'll make sure it's always there readily available. We look forward to hearing from you.
So thank you, everyone. That represents the end of the session. Thanks for your attention, and we really look forward to engaging you throughout this STEM challenge. And as Stephen said, please do get in touch if you have any questions. So yeah, thank you very much.
Best of luck, everyone.
Good luck.
Good luck.